Now, scientists have unveiled a highly anticipated first image of a black hole.
For centuries, black holes have captivated us with their powerful gravitational pull and impenetrable event horizons. Now, after years of speculation and investigation, scientists have made an awe-inspiring breakthrough. In this video, find out what lies inside a black hole and discover a world of wonders that have long been hidden from sight. The groundbreaking discovery promises to unlock new insights into the fundamental nature of the universe and challenge our current interpretation of cosmology. These enigmatic objects, born from the collapse of massive stars, create a region of space so dark and intense that not even light can escape its grasp. For years, scientists have been struggling to uncover the secrets lurking within black holes, relying on only indirect evidence and the effects of their gravitational pull to understand their nature. But now, after years of exploration and tireless research, a glimmer of hope has emerged. In April 2019, a team of international scientists made a groundbreaking discovery that has sent shockwaves through the scientific community. They were able to capture the first ever image of a black hole, using a network of 8 telescopes all positioned around the world. The image itself is a sight to behold, a bright ring of gas and dust surrounding a dark void. The black hole itself. The mere existence of this image has sent shivers down the spines of scientists and researchers alike, as it offers a tantalizing glimpse into the inner workings of these cosmic enigmas. This discovery has been hailed as a major milestone in the field of astrophysics, providing new insights into the fundamental nature of the universe. As renowned physicist Stephen Hawking once said, "Black holes are the most mysterious objects in the universe. We know what happens near them, but we don't know what happens inside them." The breakthrough also challenges our current understanding of physics. According to Einstein's theory of general relativity, nothing can escape from a black hole once it has crossed the event horizon. However, some theories suggest that black holes may contain a singularity, a point of infinite density, and zero volume, which could provide new insights into the behavior of matter and energy in extreme conditions. The mystery of black holes may never be fully solved, but this discovery brings us one step closer to understanding the fundamental nature of the universe. The event horizon of a black hole is the point of no return. Once an object crosses this threshold, it is trapped by the black hole's gravitational pull and cannot escape. For decades, scientists have wondered what happens inside the event horizon, but until recently, no one had been able to see inside a black hole. In April 2019, a team of international scientists made a breakthrough discovery that allowed us to do just that. The black hole in question is located in the Messier 87 galaxy, 55 million light-years away from Earth. The image was captured using a technique known as very long baseline interferometry, which involves combining the signals from multiple telescopes to create a virtual telescope with the resolution of a telescope the size of the Earth. The process requires an enormous amount of data equivalent to several petabytes and involved collaboration from more than 200 scientists from around the world. The image provides new insights into the behavior of matter and energy in extreme conditions. It also confirms some of the predictions made by Einstein's theory of general relativity. The bright ring around the black hole is caused by the intense gravitational pull of the black hole, which warps the surrounding space and time. This phenomenon, known as gravitational lensing, was first predicted by Einstein's theory more than a century ago. Among the most significant challenges to our understanding of physics came with the discovery of quantum mechanics in the early 20th century. Quantum mechanics is the branch of physics that deals with the behavior of matter and energy at the smallest scales, such as atoms and subatomic particles. It has challenged our understanding of the nature of reality and the very fabric of the universe. As physicist Richard Feynman famously said, "I think I can safely say that nobody understands quantum mechanics." Despite the difficulties of understanding quantum mechanics, It has led to many important discoveries and technologies such as transistors and lasers. Understanding physics came with the discovery of dark matter and dark energy. These are invisible substances that make up the majority of the universe but cannot be detected using traditional telescopes and instruments. The existence of dark matter and dark energy has forced us to rethink our understanding of the fundamental forces of the universe, and has led to new theories about the nature of space and time. Recent breakthroughs in physics have also challenged our understanding in the nature of time. In 2011, scientists discovered that neutrinos, subatomic particles, that are produced by the sun and other sources, appeared to be travelling faster than the speed of light. This would violate Einstein's theory of relativity, which states that nothing can travel faster than the speed of light. Although it was later discovered that the experiment was flawed and the neutrinos were not actually travelling faster than the speed of light. The incident forced physicists to rethink their assumptions about the nature of space and time. From quantum mechanics to dark matter to the nature of time, new discoveries and breakthroughs have forced us to rethink our assumptions about the world around us. Astrophysics and cosmology are fields that seek to understand the universe and its origins. Black holes also play an important role in the many cosmological births. Do you know that our galaxy is going to merge with Andromeda Galaxy to give birth to a new galaxy? The good news for us is that this cataclysmic event won't happen for another 4 billion years from now. Galaxy mergers are a cosmic phenomenon that involves the collision of two separate galaxies, and they often lead to the formation of a new elliptical galaxy. An enigmatic entity whose immense gravitational pull is so strong that not even light can escape its clutches. Supermassive black holes are believed to form when massive stars run out of fuel and collapse in on themselves, creating a region of incredible density at the center of a galaxy. Over time, these black holes grow larger by consuming nearby matter, such as gas, dust, and even other stars. Recently, the James Webb Telescope captured an incredible image of Sagittarius A, the supermassive black hole that resides at the center of our very own Milky Way galaxy. This discovery highlights the importance of supermassive black holes in understanding the universe around us. During a galaxy merger, the central supermassive black holes of each galaxy also begin to interact. As the black holes orbit around each other, they emit powerful gravitational waves that cause them to spiral inward until they eventually merge into one. One of the most significant developments in regards to black holes is the discovery to black holes' gravitational wave. Gravitational waves are ripples in space and time that are produced by the movement of massive objects, such as black holes and neutron stars. In 2015, the Laser Interferometer Gravitational Wave Observatory detected the first ever gravitational waves, confirming a prediction made by Einstein's theory of relativity over 100 years ago. Einstein's theory of relativity is a set of two interrelated theories, the special theory of relativity and the general theory of relativity. The special theory of relativity, published in 1905, describes the laws of physics in the absence of gravitational fields, while the general theory of relativity, published in 1915, explains the behavior of objects in the presence of gravitational fields. The theory of relativity fundamentally changed the way we understand space and time. It implies that even though the speed of light is a constant that never changes, space and time are not a constant. They are experienced differently by everyone based on their perspective. The general theory of relativity extends this concept to gravitational fields, describing gravity as a curvature of space and time caused by the presence of matter and energy. This theory provides a mathematical framework for understanding phenomena such as black holes, gravitational waves, and the universe's large-scale structure. The discovery of gravitational waves is living proof of the general theory of relativity that was predicted so many years ago by Einstein. The discovery of gravitational waves and being able to see inside a black hole are amazing developments in our quest to understand the origins of our universe. These new discoveries give us a glimpse into the mysteries of the past and present. Thank you for watching. If you enjoyed this video, please make sure to like and subscribe for more content like this.